Everybody, how's it going? So I have a really special video for everybody today. I'm going to do my own adaptation on this paper. So I'm going to build the structure, this graphitic carbon nitride with cadmium sulfide. So here's a picture of the structure. I'm going to do it a little different than the way they do. I'm going to make it a little bigger, but more or less it's the same thing. So this is a heterostructure between graphitic carbon nitride and the 110 surface of cadmium sulfide. So let's go ahead and do this. So what we're going to need here is the graphite from Materials Project. So to download it, you just go here, conventional standard. We'll also need cadmium sulfide, the cubic one, from get the conventional standard. Okay, so this is a really special video, so I hope you guys enjoy this. It's going to be perhaps quite long, but I wanted to make something really nice for all of you guys. So let's go here into VESTA. So yeah, I was playing around with it and I got an idea of how I want to do this, but I am kind of freestyling at the same time, so I might make mistakes. So first thing we'll do is we'll go from graphite to graphene. Now I did show this in my materials modeling course I made on heterostructures, for heterostructures between hexagonal lattice types using root integer supercells. Anyway, so what I do is I delete the bonds there. I'll delete these, and then I'm going to delete the periodic replicas. So we're going to save this as an XYZ. So I'm going to move fast here. This is a advanced case, but if you want to just slow down or watch the video again, feel free. So here I'm going to save this as an XYZ. So export data. Let's do it as graphene XYZ. So I think this was a free portion of so I did make a course on heterostructures, and this is a free part of that course. So now what we're going to also do is save this as a VASP. So this actually is, when you save it as a VASP here, it's actually going to keep all the atoms we deleted. So Cartesian coordinate. So let's go to PyCharm, which I used as my IDE here. Graphene.vasp. Graphene XYZ. So Graphene XYZ, you can see it only saved what was on the screen, whereas the VASP saved what was there before. So I copy in these two coordinates into graphene.vasp, delete these. We now only have 2 carbon. Call this graphene, and let's make this 18. So let's go ahead and now open graphene. So technically this is a monolayer of graphene now. Okay. Well, graphene is a monolayer. It's a monolayer of graphite. So now what I'm going to do actually is I want to make graphitic carbon nitride. So I believe how they do that is they have every other carbon be a nitrogen, right? So 1, 2, 3, 4. So it's like these 4 carbons, and then there's 1, 2, 3, 4, 5, 6 nitrogen. So let's go ahead and try to make that. So what I'm going to do here is go to edit data, unit cell. I'm going to make this 3 by 3 in the XY. Okay, so what I just want to do is carve out that piece where it's going to be, and I'm going to save this as an XYZ. So let's go ahead and carve this out. Okay. So yeah, these internal 1, 2, 3, 4, 5, 6, these will be nitrogen. So let's go ahead and save this. We're going to export this as an XYZ. So g-c3N4, so something like that. I believe that's what it's called. C3N4. Okay. And we'll save that as an XYZ. Okay, let's open that up. So I'm pressing Command W. You would press Control W on Windows to exit this out. Okay, so now we have our graphitic carbon nitride. This is actually a graphene flake right now. You would need to cap this with hydrogen if you wanted to use this normally. So let's go ahead and figure out. So this is atom number 4. So we go to edit data, structure parameters. Go to atom 4. This becomes nitrogen. Call this nitrogen 1. Okay, apply. This is atom 5. Nitrogen, it'll be nitrogen 2. Atom 2. nitrogen, call it nitrogen 3. Don't worry about the labeling being in order. Carbon 6. This is now nitrogen, nitrogen 4. Carbon 3. This is now nitrogen, nitrogen 5. And this is carbon 1. So this will be nitrogen, nitrogen 6. Okay. So if you wanted to show the bonds, you would have to go to Edit Bonds. Make a bond between carbon and nitrogen. Max length 2. This is just for the perception algorithm. Okay, there it is. So let's save this, export data, and we're just going to overwrite what was there. So let's save it. Okay, so we have our graphitic carbon nitride molecule now. All right, let's exit out of here, Command W or Control W, and let's open the cadmium solenoid. Okay, great. So let's go ahead now, let's do A. Let's go to Edit Lattice Planes. We're going to look at this 110. Okay, let's center it. So that's the 110 face. So I happen to know through experience and other means how we can transform this. So this face is now going to be in the C axis. So you can select OK. Let's go to Edit, Edit Data, Unit Cell, Transform. So we're going to throw this rotation matrix here. We're going to throw it into the mix. So if you were to take the 110 vector, just imagine a vector 110 here, and do the dot product with this matrix, you'd get the 002 vector. So 110, you would get -1 plus 1 plus 0. So this would be 0. I think it might be 110. You would get a similar thing here, and then here you would get 2, right? So to get 002. So this matrix transforms the 110 vector into the 002 vector. So just take the vector here, 110, do the dot product with this matrix, and you should get the 002 vector. So select yes, search atoms, apply. Oops, looks like I did something wrong. Let's see what I did wrong here. Oh, this is supposed to be 0. Okay, yeah, so you can see now that this is the new, that this face here is the 001 face, which is now the, sorry, this face here is the 110 face, which has now been transformed to the 002 face, which is equivalent to the 001 face. Select OK. So it does look like perhaps that we might have a little too much, something maybe went on here. So I'm going to exit out of here and just redo the transformation to make it clean. The reason is because when you click that search structure and add atoms as new, it can be problematic if you happen to have messed up. So we'll just go back and repeat this. Okay, we centered it. Okay, so here, just to go back to lattice planes, this is 110, right? So this is the 110 plane. And we're going to apply a transformation to this such that it transforms the 110 vector into the 002 vector, right? Okay, so yeah, it's this one that was problematic if you happen to mess up this step. Okay, so it looks like we're good now. Select OK. So yeah, it adds them as new. So this looks better. So let's go ahead now and save this. So file, export data. We're going to save it as a VASP. So CdS 110. Save that as a VASP. Okay. Cartesian coordinates, this is important. So let's Command W or Control W out of here. Let's reload it. Okay, so recall that the C axis, this plane here, is our 110 surface. So what I'm going to do now is I'm going to expand this 2 by 2 by 2. It will add a significant amount of atoms into the system, but it's just how I want to do this tutorial. So let's go to delete these bonds. They confuse me. Okay. And what we're going to do is go to Edit, Unit Cell. Let's just do 2 by 2. Let's not do 2 by 2 by 1. Let's select, well, yeah, just do 2 by 2. Oops. Okay. So it does have 145 atoms. It is quite a bit. But we will need to place the molecule on here, right? So I guess this is like one way we could do that, unless you wanted to have the graphitic carbonitrile be kind of close to each other on the surface. But let's go ahead and do this now. So this would be 1, 2, 3, 4, 5 layers. So that's probably fine. So let's go ahead and save this file, export data. So CdS 110, 2 by 2 by 1. Save. Cartesian coordinates. Let's go ahead and open that up, just so we're working with a clean system every time. So let's get rid of these bonds. Yeah, by the way, this is, you can see I might have some times where I have to reassess. All right, so we want to add vacuum in C. So that means we're going to save an XYZ where A and B, the periodicity in A and B has been deleted. So delete the periodicity in B, delete the periodicity in A. All right, that's straightforward enough. So let's go ahead and save this now. So this is, save this as an XYZ. Save hidden atoms, no. All right, so some copying, pasting now. Open up the VASP file for the surface and the XYZ. So let's go ahead and copy all of these coordinates. Now, hopefully stoichiometry will be preserved. Okay. So it is quite a bit of atoms in the system. All right, so let's see how many cadmium we have. So this is line number 9. This is line number 68. 68 minus 9 is 59, plus 1 is 60. All right, so there's 60 cadmium. And sulfur, 69 and 128. So 128 minus 69. Oh man, that is tough. It's 59 plus 1 is 60. Okay, so we're good here. We have 60 cadmium and 60 sulfur. So we do have stoichiometry. So I'm going to change the name of this to 111. Okay, so let's go ahead now. I'm going to do find replace. So I'm going to replace cadmium with several spaces after it. Maybe with just a blank line. So I have to redo it here. And then sulfur with several spaces after it. Replace. Okay, so this basically reads the first 60 atoms are cadmium, and the next 60 are sulfur. And we're going to add 20 angstroms of vacuum. So let's go back to VESTA now. So yeah, you could see this is now our surface. Looks really good. Let's go ahead and delete bonds. Okay, and then we can delete the periodic replica of this bottom one. So there you go, there's our surface. Okay, now that is the 110 surface. It looks kind of weird, but I guess that is it, right? So if we were to remove this top layer, it would be the next surface. Okay. So let's go ahead and add our molecule now on top of this. So there's a couple ways we can do this. Let's go ahead and just do it this way. So let's go to File, or Edit Data Phase. And by the way, this title here that appears here, that's this here. Okay, that's this first line. So let's go to new, import, and let's import graphitic carbon nitride XYZ. Oops, not new, sorry. We just needed to go to import, not new. And not graphene, so let's just import this. Oh, it's saying graphene here because that's what's here. So we're gonna call this g-c3N4. It's reading the N4. It's reading the comment. Let's delete this. Import. There we go. So let's apply. So it is kind of stuck in the middle here. So what I want to do is move this up a little bit in Z. So let's move it up. Let's do this option to move our structure here. Let's move it up maybe 5 angstroms. Okay, that's pretty good because it's space filling, right? So if we go back to ball and stick, it looks like this. So space filling. Now let's move it 5 and what is this? X. Oh, that was this way. No, it's not X, that's Y. 5 and X. So it does look like we could have gotten away, hypothetically, with using only half the slab, but then these would have been, this would have been really close to its neighbor, right? So I guess it's all about how close you want it to your neighbor. This is just the model I'm doing. So it looks good in A. We have to move it a little bit more in B. So let's move it to 7.5. Oops, looks like it's actually this way. Okay, so I think this looks pretty good to me for our system. Select OK. So what I do now, and you didn't have to do it this way. I then redo this thing here where I delete periodicity because I save everything as an XYZ. Let's export data. Let's export this as C3N4. Gosh, that is hard to remember. Save that. Then I'm going to export everything as a VASP one more time. Okay, so let's now go back to PyCharm finally. You could have just placed the fragment directly into the old VASP file, but then you would have had to center it using some like Python script or something. All right, so 136, I'm just going to actually copy this entire file. There is one more thing we're going to have to do after this. Okay, let's go into the VASP. Okay, so we have 1, 2, 3, 4, 5, 6 nitrogen. So we have 6 nitrogen, and then how many carbon? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, let's do this. 10. So I'm going to find replace now. Sulfur is fine. Looks like we will have to redo that. Replace the cadmium, replace the nitrogen with the blank line, and then replace the carbon with the blank line. All right, so this is all fine here. I am going to just add a tab here because it does look like some are pressing against the side. Okay, and so this will be 60 cadmium, 60 sulfur, 6 nitrogen, and 10 carbon. Now let's have a little bit of self-respect and align these. Okay, so g-c3N4, just some bookkeeping. All right, so this should be good now. This should be the final file. So you would just, if you wanted to use this in Quantum Espresso or VASP, I think you would just re-add in the atom labels. Actually, in VASP, you actually just use this thing here. If you want a Quantum Espresso, you'd have to re-add the atom labels. So let's go to VESTA, open up this, and boom, there we go. There's your final structure. So let's make the thumbnail. Should it be this? No, it should be this. Yeah. And let's delete the bonds, because bonds don't matter in space filling mode. Between those two. Perfect. All right. So there it is. There is the interface between a graphitic carbon nitride flake, as done in the paper. Now, I would have added a hydrogen maybe out here. You might need to look into that. These carbons that are only bonded to a single nitrogen might need a hydrogen on them. This carbon here is bonded to 2 nitrogens, so it might not need a hydrogen on it. But the carbons that are only bound to 1 nitrogen likely need a hydrogen. But yeah, so that's it. That's our, let's do it this way. This is our thumbnail. Maybe this, no, I like this view. Which view do I like? Anyways, yeah, so leave some comments in the comment section, subscribe, and you guys let me know. All right, take care.